Hey, thanks again for coming over and spending time with us. My name is Arif Huq. I lead product management at Aporeto. So what I'm going to do is go through some of the use cases that we've actually been working with customers. So these are actually use cases that have been deployed with our customers so far. So before I do that, I want to kind of ground, again, kind of just summarize the discussion and the things that Dimitri has talked about so far. And then we'll kind of overlay the use cases on top of that. So far we've talked about two actors in the enterprise, right? There's a user, and then there's an application. And the application can be a VM, can be a container, can be a process, can be a function, right? So we've addressed that these are the types of applications, and there's a user. Dimitri talked a lot about the identity framework that we've built on top of this, right? So there's an application identity. We're able to extract identity, figure out what that application is, give it an attested identity. We're able to figure out what a user identity is through an identity provider, because you authenticate and authorize against an identity provider, and that's one way of figuring out user identity. We can be an identity broker, and we're going to show you some of those use cases. Why it's important for us to even give applications an identity that they can use it for certain things. So let's layer the use cases on top of that. Even before we start talking about network security or API security, how we solve security with containers, start even at the host layer. Who has access to hosts? And I'm talking about SSH. This is a big problem today. Like, how do you control who has access to your infrastructure? And that's a problem, and you need to be able to solve that problem. So we're going to talk about that. We'll talk about network security at layer 3 and 4 and the use cases there. API authentication and authorization. So how do you solve the problem of what microservices have access to which APIs and what methods? Transparent encryption. How do you offload encryption logic from your application so you don't have to go embed TLS libraries? You have to go manage these TLS libraries. You have to go manage key rotations, certificate rotations, things of that nature. Solve that problem. And finally, PKI. How can we be a public key infrastructure to give certificates to applications, right? So all of this, again, relies on identity and works across users and applications. OK, so let's talk about the hybrid cloud use case. So lots of our customers today, when they think about security, they're adopting a hybrid cloud scenario or multi-cloud scenario. The first inclination is, let me try to replicate a perimeter security model. Let me try to put in a firewall, a third-party appliance in my cloud environment. The first question that's being asked is, where do I put this appliance? Let's talk about a VPC, a virtual private cloud instance. Which availability zone do I put a firewall in? How do I get traffic to this firewall? So there's a lot of questions you end up asking yourself, and the answers are not easy. Because say, for instance, you take an AWS VPC, you've got 3 availability zones. The answer is you put your firewall in all 3 availability zones. How do you build redundancy? You have to build an HA across all 3 availability zones. How do you attract traffic? You have to kind of change your VPC route rules to go attract traffic towards these firewalls. So there's a lot of complexity in trying to replicate a perimeter security model in a cloud environment. And if you try to stitch this across multiple clouds, the first inclination is, let me try to build a perimeter across multiple cloud environments. And I do that using VPN tunnels and gateways. And again, there's things that I have to deal with there. So that's one part of complexity. How do I do granular access control with cloud native capabilities? Like, for instance, in AWS, you have security groups. But security groups only apply on a per VM basis. They don't apply to containers. So I have containers. How do I apply these cloud security constructs to these containers? And lastly, how do I solve the problem of visibility, right? In a cloud environment, I can get VPC flow logs. I can get flow information only specific to that environment. As soon as my application traverses that cloud or that VPC, I start to lose visibility. I have no idea what these flows are, what they're communicating with, right? I need to stitch these flow information. So with Aporeto, the things that we've solved here are, first of all, reduction in network complexity, because we're not talking about VPN tunnels anymore. We're talking about, as Dimitri highlighted, an any-to-any connectivity model, but you authenticate and authorize all requests, right? We have a distributed kind of a security model here. You don't have to have a third-party appliance that's sitting in your VPC. You don't have to manage HA for it. It's sitting on the host, right? It scales with your application infrastructure. Gives you very granular security down to the container level, down to the process level, which helps you augment existing security controls that you have with your cloud providers. And lastly, the visibility, right? I mean, how do I stitch VPC flow information across multiple cloud environments with IPFix information that's sitting with my firewall on-prem? It's really a hard problem to solve. But as Dimitri talked about, the fact that we're exchanging identity information as part of the TCP handshake, as part of that HTTP payload, we're able to stitch the communication pattern between applications very easily. So the application visibility, which will be part of the demonstration, is a critical problem we've solved in the use case for our customers.
So I have one concern, in a way.
Sure.
By default, most of us are going to deny all traffic unless explicitly allowed.
Yes.
At which point we're having to create a metric ton of policies. But if we were to say, let's open up all traffic and connections because we know it's being protected at each of these points in here throughout the infrastructure, I can then open everything up. But then I don't want to open everything up because if something gets deployed that we didn't protect in some mechanism, now I've got an open hole, and therefore I'm back to deny all, but then opening the same type of stuff up I was already doing in my ingress and egress and all those points. Does it make it better or easier or an export mechanism? I don't know. I'm just trying to still maintain my security posture while not compromising myself, but not doing the work twice.
Fair enough. So it's a whitelist model, right? You allow what you want to allow, right? And your question, I think the root of your question is, how many policies do I end up enforcing?
That's definitely a part of it. And it's not how many I'm enforcing. How many policies am I creating and how many places?
Fair enough. Well, you only create them in one place, right? And
well, if I only create them in one place, then do I allow all traffic by default?
No, you don't. So
I mean, in Amazon and in GCP and on premises and in my VMware environment from my firewall to the internet and Azure and all these environments. But normally I'd say deny all traffic unless I specifically allow
Exactly.
it.
So let's take an example, right? Let's take an application component that's sitting in AWS and another application component that's sitting in GCP.
It's perfect example, yeah.
And you want only these two application components to talk to each other.
Yes.
Okay? What you're going to say is, what is the identity of this application component A? And by the way, this application component A can be 5 front-end instances.
Yeah,
it doesn't
matter.
necessarily need to be one instance. It can just be 5 front-end instances. You say app equals front-end. You can even clarify it by saying app equals front-end sitting in AWS, trying to talk to app equals back-end sitting in GCP. That's it. That's a policy.
So will the policy server go in and instantiate the security policy on behalf of GCP and in AWS?
No, so we're on the host, right? We are the ones enforcing the policy.
I get that part. It's just has anyone else seen what I'm talking about?
So I've been thinking about this a lot, right? Like I totally dig what you guys are doing and understand it, but the management looks like it could become a really big deal. Let's say I have an app, I have 40 API endpoints, and they get changed 3 times a week. That's 120 changes, right? Because we're in an agile environment. How do you handle 120 changes from dev teams who are in a DevOps model, right? Because if you're static and your bank app never changed, this makes perfect sense.
So let's start by layer, right? Let's start with network policies. And then I'm going to get to your API endpoints as well.
Yeah, because that's where I think the most value.
Let's talk at the network layer first. And just to complete that example, all I said was app equals front end, trying to talk to app equals back end. I don't care how many instances of app equals front end, how many instances of app equals back end are.
Well,
right?
I'm going to make it even easier. I have 2 applications running as very simple services in this same Amazon cluster, right?
Yeah.
So I've got a web server talking to a database server.
Yes.
So unless I go and say web server can talk to database server and then instantiate what they can do, they technically could do things before I install the enforcer into the construct to say that these things can talk in here and we're going to tunnel the connection. That I have to have a way for them to be able to talk to each other. Therefore, I have a security policy part that says these devices can talk to each other. So before I even touch the product, I stand up my first VM so I can load things into it or whatever AMI, any of those things. I need to say devices can talk to other devices, at which point I'm touching my first security policy before I touch the product. The product does amazing things, but I have to go and say stuff can talk to each other. And I prefer to say you only can talk 443 and SQL or whatever it happens to be. We limit it down to what we want it to, at which point I'm doing work twice potentially.
No, okay, so here's the thing, right? So what you highlighted is correct. You need a security group to say these two VPCs can talk to each other, or you're exposing the specific traffic on this specific instance. Absolutely, those are coarse-grained policies you can start to implement, right? You don't have to go in.
Can.
You will have to do that.
Okay.
Yes, you will have to allow traffic. I mean, that's the security group. That's how security groups work, right?
Yes, no, I get that.
But it's very coarse. You don't have to go in and do things like what you just mentioned. What port do I have to allow this traffic on? What specific IP address from this VPC should I allow this traffic on, right? That's where we come in and say, you can decouple that from your security group. Your security group is giving you the IP connectivity, right? It's just allowing communication. And I think it'll be, I don't want to, I think what's happening here is we'd like to demonstrate this to you.
Well, that's what I'm saying. The easiest way is actually just show us what the not Aporeto policies are, but on the AMI, any of those type of policies. That makes it easier.
Yes. So we will show you exactly how it works. Yeah. And I think I will address your API question as well.
Okay.
Yeah. Okay. So let's talk about Kubernetes network security. So Kubernetes allows you to essentially it's an orchestration platform. It's going to bring up your container environment very quickly. An IP whitelisting mechanism in these types of environments doesn't work very well, right? So one of our customers essentially built a new Kubernetes-based application that has dependencies on-prem. And so what they were doing was, so the Kubernetes application was a microservice. They were deploying to this microservice multiple times a day. And what that would result in is changes in that environment, right? Containers would come and go. IP addresses would change. What they would have to do is, in the firewalls, they would keep adding rules or removing rules as a result of changes that would happen in their cloud environment, because they have no idea, no control over the IP address infrastructure in that environment. And now what we're able to do is solve this problem using identity. So that was one aspect. How do you solve this problem of segmentation across multiple clusters? So say, for instance, you've got your database that's being replicated across multiple environments. You only want these database components to talk to each other. In a Kubernetes world, it's actually really hard to solve this problem. It's actually being solved using IP address today when you want to communicate outside the cluster, right? And then encryption was also part of the requirement. So one of the questions that was being asked earlier was, how do I solve this problem of defining rules in these dynamic environments with automation? Right? So again, we talked about identity, right? Identity as a way to define what application component talks to what other components. This identity is portable. It doesn't matter where this application component is, and it's decoupled from the infrastructure. So we can write these policies as code. And if you look at Kubernetes, you define policies through something called network policies. It's a Kubernetes construct. You deploy it as part of your Kubernetes deployment file. And all of the policies that we're talking about today can be defined through Kubernetes network policies. So you kind of operationalize how Aporeto works together with how you deploy your applications with Kubernetes. So that gives you this continuous deployment with compliance, right? With security compliance. And
a YAML file
that's right. It is a YAML file. In fact, we'll show you that. Yeah.
Parameterize YAML file.
Transparent encryption with mutual TLS offload. That's the encryption piece of this. Okay. So we talked about SSH. So we've talked about like the network security aspects between containers, VMs, and functions. How do we even protect the host, which is actually a very critical part of the infrastructure? And there's a problem that a lot of our customers are trying to solve. Some of our customers are moving to cloud. They have thousands of hosts, and they need to manage who has access to these hosts. What you want to do is limit user access to these host infrastructure, and you want to prevent things like lateral movements. So a user SSHs into a Bastion host. From that Bastion host, should that user have access to all of your infrastructure, all of your hosts? No, they shouldn't. In fact, they should be governed by specific compliance and specific times that they need access for, right? We can solve this problem because the user shows up as an identity in our platform. And you can use this identity to determine what that user has access to. And now you can't laterally move. A user that requests access can only get access to the systems that they've been given access to for the time that they've been allocated for. They can't laterally move within that environment. And the use case here has been used to solve GDPR compliance For instance, users should only have access to hosts that they are actually able to, they're able to kind of work with GDPR compliant data. Then they should only have access to that host infrastructure. If they're not able to work with GDPR compliant data, they shouldn't have access to that host infrastructure. So SSH control is actually a big part of what we're actually solving as well. Modernizing traditional web apps with OAuth. So Dimitri talked about how we're solving this problem of API authentication and authorization. But one of the things that we see a lot of our customers struggle with is they're moving their applications to cloud. They're modernizing these applications. They're containerizing them. And they want to implement stronger authentication and authorization, right? And when we talk about stronger authentication and authorization, we're talking about not using passwords, username and passwords to log into an application. How do I enable modern authentication such as single sign-on, multi-factor authentication for legacy applications? Right? That's actually a big problem. How do I enable this application for API requests between B2B and B2C clients? Right? So my users have specific capabilities that they can execute with this application, but my partners don't have those same capabilities. They have a different set of capabilities, right? So simply what we're able to do is we are an HTTPS proxy in front of this application. The user logs in with their identity provider, gets their specific identity context, presents that identity context to us, and using this identity context, we're actually able to allow this user access to this application, deny this user, allow this user to specific parts of the application. Same thing for partners. Partners are given specific identity context, whether it's through an identity provider or they're using our technology to get identity themselves. That identity is presented, and we're able to give specific access to those partners. And you can do all of this with zero code changes. That's the most important thing. If I were to go and take a legacy application that doesn't have single sign-on or multi-factor authentication capabilities and try to retrofit these capabilities, it would actually take quite a bit of software rewrite to solve these problems. But we're solving this problem with zero code changes.
I have a question on the,
Sure.
you don't have to go back, but the GDPR comment. How does it address the GDPR aspects? I understand that there's a lot of requirements in there around restricting access to least privileged concepts. But what's the I guess what problem does it solve, and how does it do it?
Yeah. So we were talking to one of our customers who they have infrastructure all over the world, right? And as part of the GDPR compliance, specific users within the enterprise have access to hosts that have GDPR compliant data. So data that is only specific to perhaps users in EU, right? Only specific users have access to that information, right? As in, you can only SSH into those hosts if you're part of a GDPR group, right?
Okay.
And because we're talking about SSH in that specific use case, users in North America that shouldn't have access to hosts that have GDPR compliant data shouldn't be able to SSH into that host or be able to log in and exfiltrate data from those hosts. So we're able to solve this user to host access control using user identity, and those users that are able to access GDPR compliant hosts are able to log into those hosts.
Okay, so that would be assuming the organization understands where that data is and that it's structured enough to be identified on certain systems but not others.
That's right. I mean, you would have to know where your GDPR compliant data actually resides. What part of your infrastructure, if you have an application that is hosted in EU and you know that it has information that is bound by GDPR compliance, then yes, you know the host infrastructure that's bound by that compliance. Right?
So other than maybe just, and this might be a bad comparison, but I'm just off the top of my head, maybe some segmentation and proper ACLs, how does Aporeto add some benefit over that as far as, SSH, to your point, don't even allow SSH at all, cut it off. What's the added benefit for that?
No, but you can't cut off SSH because some users should have access to their hosts, but not others, right?
Okay.
So how do you solve that problem from your enterprise, right? And if you try to use ACLs, what prevents me from logging into a set of hosts and then from there bouncing from that host to other hosts that I have access to? That specific host may have access to other hosts,
Okay.
but as a user, I shouldn't have access to those hosts.
Okay, because
Right?
so that identity is going to follow the user.
That's
if they bounce
exactly
from box
right.
to box.
That's exactly
Okay.
right. That user identity is persistent, right? I know who that user is.
Okay. Yeah, because I think the biggest concern that I had with that, I guess I would say, is, giving someone that false sense of hope that just by putting this in place, they know it. But the real struggle that I've seen, it was mainly we don't even know where the data is. So how are we going to restrict it down to those boxes and so on and so forth? And if you see an organization that says, yeah, it's mainly on this box, and they lock it down with a tool like Aporeto, and that's awesome that the identity follows that user as they go around. But maybe that's that false sense of hope that we don't have to worry about where the data is anymore because of it. So
no, unfortunately, yeah, you absolutely need to know where your data is.
Yeah, and that's why I was asking. I was just very curious on
Fair
that.
enough.
So thank you.
Yeah.
I appreciate that.
No problem. We're going to elaborate a lot more on this. I'm just going to quickly cover it. But user access or client access to tools that are used in your environment, like for instance Kubernetes. Who should have access to a Kubernetes control plane, and what methods should they have access for on that Kubernetes control plane? That's an important problem to solve. And in fact, that's one of the things we'll demonstrate to you and how it actually helps solve a recent issue that was identified in Kubernetes. So what we want to do is decouple security controls from cluster administration. Right? Cluster administration should be, it should be hosted within your own cluster. You should be able to decouple the security controls off your cluster away from, in this case, Kubernetes. If you're using open source tools like Grafana, Prometheus, Jaeger to actually do things like tracing and login and performance management, a lot of these tools actually don't have ways to manage who has access to these tools. But this is absolutely critical data that you want to prevent users to get access to, right? In fact, we actually identified this as a problem even for ourselves. We use a lot of these tools to do performance management, and we figured, hey, these are kind of open. We need to solve this problem of who has access to these tools. And using the Aporeto Enforcer, we're able to prevent user access to these specific applications. And lastly, this use case around certificates for applications. So, secrets and certificates are critical to applications, and you don't want to store them within your application, right? You don't want to put secrets within your code because it's bad practice. You're gonna publish on GitHub someday, and then somebody has access to your secrets. Really bad idea, right? You want a model to kind of give secrets to your application based on that identity, and it should be time bound. They should only have access to the secret, execute what he needs to do, and then that secret should no longer be valid.
So is that then a one-time secret that only existed for the duration of that transaction?
That's correct. You can time bound it, right? You can say this secret should only be valid for 10 seconds, right?
But what if it takes 11 seconds?
Well, you can definitely yeah, absolutely. You can increase the time frame. It can be a one-time secret as well.
Because can it be a one-time secret that's only valid for the duration of this transaction? Whether this one took a second, this other one took 30 seconds. This query was 90 seconds, and then the rest of them are 2 seconds. I don't want it to necessarily be 90 if I do have the ability to say it's transaction bound, in which case I love that. That sounds exciting to me.
It's time bound. It's not transaction bound.
Okay.
But you can rotate them. You can always expire them, and you can revoke them as well.
Sounds about 91 seconds seems like
So
about
you
fair.
can do revocation?
Yeah, you can definitely revoke certificates.
CSP or what?
Yeah, you can definitely do certificate revocation.
We manage the whole PKI infrastructure, and as part of that, you can revoke certificates.
You have a CRL and a public
Yes.
URL, and okay.
So, but this is within our system, though, right? This is internal. All our enforcers will validate certificates with our system.
Right, okay.
It's not need to replay back these mechanisms, at which point it invalidates the prior part because it's so short-lived.
Yeah, that's what I was going to say. If you're only keeping them alive for 30 seconds or 30 minutes,
Yeah,
then revocation's not much of an issue.
Right.
It becomes like let's encrypt.
exactly. But with a mechanism to actually renew that works.
Yeah, that's right.